Okay, so here's our pretty primitive and lame program from the previous video, but again in that video I hit F11, Control Alt D, F11, and we can see that we're moving across instructions as I hit F11, and the instruction pointer updates as we execute these instructions one by one. Well, let me go back to our code here, and I want to modify the instruction pointer. I want to change where the instruction pointer is pointing at. Remember, the address in the instruction pointer, if I bring that back up again like so, the address in the instruction pointer indicates the next instruction, not the previous instruction. It's the next instruction to execute. So right now, the next instruction to execute will be 003F1010. And right here we have 003F1010. That's quite nice that the debugger keeps track of that for us and puts this yellow arrow there. And as I hit F11, it steps up like so. Well, I want to change the next value that or the next instruction that's going to execute. So you may think, oh, all right, let's copy this, all right, and then Shift F5 and go into our assembly code, and let's just say randomly in here I want to say move into the instruction pointer that address, prefix it with a 0x to indicate its hex. But when you do that, Control Shift B, it's Right? Why it's saying this is we cannot modify the instruction pointer directly like this. Yes, the general purpose registers have a heyday. Change them to what you want. That's fine. But the instruction pointer, it's special. We can only indirectly modify the instruction pointer. We cannot directly modify the instruction pointer like we're doing like so. Well, Jamie, what do you mean by indirectly? I don't get it. Well, let me show you. I'm going to turn this line. I'm going to comment it out. Remember, the semicolon indicates a comment, meaning this will not be executed nor assembled. Let's say we're going to move into EAX 1 and 2, but then at this point we want to skip 3 and 4 and go directly to 5. Well, the way we do that is with a jump instruction. All right, and let's say this is where we want to go to. We want to go to right here. Sorry, might be confusing here. So here you say, well, jump, and you think, well, okay, let's put that address right there. Now I can't even remember if this is the right address for this 5, but here let's try building this. Control Shift B and saying, hey, well, what the assembler's telling us here is, if you want to jump to a location, you need to give that location a name. You can't just put in an arbitrary address like you're doing here. Why? Because these addresses can change. As the program's loaded up and I run it once and I run it twice and maybe I run it on my machine versus yours, these addresses could possibly change depending on when you run the program and the environment you're running the program in. So let's do something that we can generalize the location you're trying to jump to, and also it will make more sense to us as programmers. Instead of putting a number there, which kind of has no meaning, instead we could put something that has a little more meaning to us as programmers. So let's say, let's label it. Okay, key term in assembly language, we're going to label this location. So right here I'm going to say another location. And I can call it whatever I want to. I can call it bibbidi bobbidi boo. In fact, why not? Bibbidi Bob, I don't know how to spell that. Let's call it another location, like so. And I put the colon after there, which basically kind of indicates, hey, another location is pointing to, or when I say another location, I mean this location in RAM of the instructions. Right? Jump to here. So watch what I'm going to do. Instead of saying jump to some number, I'm going to say jump to another location. And what that does is simply changes the instruction pointer. Okay, that's what I mean by indirectly changing the instruction pointer. I can't directly move a value into the instruction pointer like this, but I can certainly jump to another location. So let's actually run this. I'm going to hit F11, it's assembled, we're good to go, we're debugging, Control Alt D, F11, get into our assembly code, and I'm gonna do a new vertical tab group. Yeah, okay. So let me, I'm going to drag this over here, bring this over here. Here is our original assembly code on the right. All right, and then here is the actual disassembled code from the executable. Let me, can I do Control Shift Left? Nope. I was trying to zoom out, but I guess it's not going to work. All right, do it. So the first thing we said is move into EAX1. So EAX will change to a 1, F11. Very good. Move into EAX at 2, so just overwrite everything you just did on the previous instruction. But sure enough, it's a 2, and then, ooh, jump. All right, now you'll notice it says jump, do it, plus 16 hex. All right, it doesn't say jump to another location. Why? Because the assembler, if you remember, like one of the first videos we did was to set up the assembler to assemble our .asm file. The assembler sees another location, and instead of using that in the code, it says, hey, it's the location of do it, which notice do it right here looks like a label itself. You can see here's the name do it with the colon there, and basically it's indicating, hey, do it starts at the memory location 008110110, like so. So jump to the location of do it plus 16 hex. Well, let's look at this value here. I'm only going to we really need to only look at these last two here. 10 hex plus 16 hex. Well, 0 plus 6 is 6, and then 1 plus 1 is 2. So that's 26 hex, which means we need to go to this location right here. Right? It's going to jump over these two move instructions like we did here and go to this instruction here, which is the equivalent to our 5. We're going to move 5 into EAX. So the assembler eliminated the label and actually put in this value here, do it plus 16 hex. You can see here if I scroll to the right in this window, 811026 hex. Well, that's the exact same thing I said we were going to go to is 811026 hex. So here we go. I'm going to hit F11. Watch the instruction pointer right here. It will change to right here, and so also the yellow arrow, the debugging arrow, will go there as well. F11. There we go. 26, and you see the instruction pointer. We were actually able to update it, just we had to do it indirectly using a jump instruction. So that's called an unconditional jump. Now, if you read about go-tos, little side note before I end this video, if you read about go-tos, you'll see any computer science professor, most of them at least, most of the computer science people I deal with or talk to, once you say go-to, it's like this unpardonable sin. Oh, we cannot use a go-to. Oh, that's so evil. If you ever write a go-to, that's bad. Yet, in assembly, I just used one. That JMP, that's exactly what a go-to is. It's go to another location. In fact, let me just illustrate here. It's actually kind of fun to do this. I'm going to label this hell, and here I'm going to say, hey, jump to hell. All right? Or if you think of it, this is another way. In higher level languages, instead of saying jump, we say go to. Right? So go to hell. But in assembly, we have to say jump. Anyway, same thing. F11, Control Alt D. F11, you can see that we move. Now let's jump to hell, which will take us down to here. And sure enough, it still works like so. Now, if you ever hear people say don't use a go-to, they're bad, they're sinful, they're probably on the ignorant bus. Right? Especially in assembly, you kind of have to use them a lot. But go-to isn't necessarily a bad thing. It all started with Edgar Dijkstra's original paper on go-to considered harmful. And what people got out of that was that we should never use a go-to. It's just a bad thing to do. It's kind of like when your parents are religious and say, don't do this, but they don't kind of give you a reason why. You know, so you just kind of follow along for a while until you get old enough to think for yourself, and then you say, oh, you know what, I can... whatever, I can do whatever I want to. I can make my own decisions. Well, let's be intelligent. Your parents are probably telling you not to do drugs because it's bad, but if they tell you not to do drugs simply not to do drugs, well, that's not good. If your parents tell you not to do drugs because it'll mess up your body, your internal organs, screw up with your brain and mess you all up that way, that's a good thing. All right? Now, on the note of go-to, it's okay to use a go-to as long as you use it appropriately. All right, if you go read Edgar Dijkstra's paper, that's what he's talking about. Is as long as you're being intelligent with your go-tos, that's fine. But if you're not being intelligent, well, yeah, sure enough. I mean, it's kind of like a prescription from the doctor. If you take a prescription from the doctor and you use it accordingly, it will help you heal. But if you don't use it how your doctor prescribes, then yeah, you're going to do something bad. That's the same with go-to. Anyway, I'm on a soapbox. I'm obviously talking way too long about go-to. Let's move on to the next video. I want to show you conditional jumping.